And then what we're going to do for a reference is we're going to kind of put an XY axis in our circle so we have an idea of what's going on. So I know that's usually you think of those as like two separate things, like the XY coordinate plane was for algebraic graphing. The circle was something you used more in geometry. But we're kind of melding the two together where they would go through the center of the circle. I'm sure mine's not going to look very centered when I'm done. But this would be like the x-axis. And this would be like the y-axis. It's just going to give us some reference, okay, so that we can refer to quadrants and so that we can create kind of a beginning and an ending location. So when someone measures degrees around a circle, so we already established there's 360 degrees in a circle, but we have to understand where they're starting from, okay? So they came up with a standard, like man-made, determined, but if we're all going to talk about it, we got to talk about it the same way. So what they said is that they're going to call this the starting point, okay? So this is basically the initial side of any angle that we're going to build. So degrees, that would be at 0 degrees. Okay? So then if someone says to go 90 degrees, where do you think I'm going to end up? At the top of the circle. Now some people might argue, well, maybe at the bottom of the circle. You're not incorrect, except for they established a certain convention that when they give you a positive number, they want you to move in this direction. Okay? Whereas when they give you a negative number, you'll measure going the other direction. So negative here isn't like a number line. Okay? It just means you're going to go a different direction, but the same amount of degrees. Okay? So we'll go ahead and we'll mark a few different measurements on our circle. So whereabouts, just a little reminder, Algebra 1, okay, just so we can talk about this. These are how they number the quadrants, the coordinate thing. Okay, first, second, third, and fourth quadrant. If I'm going to draw a 20-degree angle, which quadrant am I going to be in? Quadrant 1, right? Okay. Because to get out of quadrant 1, how big would my angle have to be? So all the way from here to here is still in quadrant 1. How many degrees is that? 90 degrees, right? And then quadrant 2 would be any angle from 90 degrees until we hit 180. And then quadrant 3 would be anything from 180 to 270 if we add 90 to 180, right? And then quadrant 4 would be anything from 270 all the way back to the beginning, which we would have traveled 360 degrees. Does that make sense to everybody? Okay, so a 20-degree angle, we would draw something like this, and we could say, okay, that's 20 degrees. Okay. This is always the initial side of the angle at 0. That's always where you want to start it. And where you end it, we call the terminal side of the angle. So initial side's always in the same place. Terminal side depends on where you want to draw your angle, right? How big it is. Okay. Can anybody think of another number where I would actually end up with the same initial and terminal marking, but the number is different than 20, but it's still in degrees? So is there any way that I could still start here and end up here, but travel a different amount than 20 degrees? Okay, so Stephen's saying, what if we went the other way around, right? What if we went from our initial side here around this way to our terminal side here? It would look the same if we just marked the sides of the angle, right? But measurement-wise, would we call this path 20 degrees? No. Okay? How many degrees did we travel? 340. And because we went the other direction, how would we have to label that? A negative 340 degrees, right? So this red path represents a negative 340 degrees. Is that okay with everybody? It wouldn't look any different, though, if you only knew where someone started and ended up. So in some of the diagrams and stuff that you'll actually see people mark the path they traveled if they're trying to distinguish between two different things, because otherwise you would have no idea. That angle could have a lot of names. Okay? So one way to name this angle is positive 20 degrees. Another way to name this angle is negative 340 degrees. Okay? Because those are two different measurements technically, like 20 and negative 340 are not the same number, They're different, but they end up in the same place. So we call those angles coterminal. Okay, so coterminal basically means they're going to end up in the same place. They share the terminal side. Okay. Can you give me another positive number that would also be coterminal with these angles? So it would have this same initial side, this same terminal side, a positive number different than 20. Yeah? No, you always have to start at 0. So we're just trying to think of another way that I could start here and end here, but not go just this route, not go this route. What's another way I could start here and end here? And we want to go positive, right? So say I start here, I'm going positive. I don't want to stop there because that's the same as 20, so I'm trying to create a different way to get there. So let's say I keep going. Then I could end there after I've lapped around the circle one time, right? How many degrees would that be that I traveled in total? So I went once around the circle and then a little extra to get back to that same. So 380, okay? So 380, 20, and negative 340 degrees would all be examples of coterminal angles because they all have the same initial and terminal side. But depending on which way you got there, you could call them a different measurement technically. So how many different measurements could you give this angle that we've marked on our circle? Infinitely many, right? You could just keep adding 360 and have like, oh, I went 5 times around the circle and then went that extra 20, and you could get the amount that you wanted. Or you could keep going backwards 360, right? Subtracting 360 and ending up at the same place as well. So you could name them with infinitely many names. Is that all right with everybody? So direction, this idea, if somebody uses the word coterminal, you know what they're talking about. Okay. All right, so degrees-wise, I'm going to mark those important things we talked about earlier about making it through the quadrants just to remind us what that looks like. Okay. All right, so what does this look like in radians? So radians, different unit of measurement, but measures the same thing because this radian idea still measures an angle. So it still starts at 0. We just don't make the degree mark because now we're talking about radians. So give me a radian measurement we do know from what you just saw. How far is all the way around the circle? 360 degrees. How many radians? 2 pi, right? Based on what he said, 6 point whatever, but if we use the exact value, we use 2 pi. So a lot of times when we write the radians for the exact value, we're going to use something that has pi in it or something like that to represent that measurement. So if you went all the way around the circle in radians, we would say you traveled 2 pi. Okay? So it ends up at the same spot as 0 because you just go around the circle. So what if I didn't go all the way around the circle? So all the way around the circle is 2 pi radians. What if I went from 0 over here, that this was my terminal side? So I know degrees, that means I've gone 180 degrees. How many radians does that mean that I've traveled? Pi. Good. Okay. I know. A little different. Okay. Like a new unit of measurement. What about if I went 90 degrees? Any idea what that is in radians? Not pi over 4. Yeah, half pi. So this 180 was 1 whole pi, right? So 90 is half of that, so it would have to be half of pi. And so how you'll most commonly see that written is pi over 2. Okay. So any idea which degree would correspond with what Shelby said? She said pi over 4. Where would that end up? 45 degrees, right? Because it's like half of the half. So it would be a quarter. So it would be like here. So this angle would be 45 degrees, or in radians, it would be pi over 4. Okay. Those are easy because we have those quadrants marked up, and we can kind of easily mark them. They get a little more difficult. You have to be kind of good at fractions. So like if that's a half a pi, then we're at 1 pi. 270 degrees would be how much in terms of radians? Good. 3 pi over 2 is like 1.5. Does that make sense? I've gone 1, and then I need to go half more. And so we would write them as these fractional values. Now, it doesn't really make sense for me to memorize everyone on the unit circle. How many of you guys have heard about a unit circle before and memorizing? Okay. So we are going to learn this, and there are going to be some ones that we learn very specifically and we memorize. But like when I say 20 degrees, does it immediately pop into your head for that number how many radians that would be? No, it's like not nicely divisible by all the other stuff we were looking at. So at that point, if we want to convert it to degrees, we want to do something where we have a conversion factor. For example, when you guys convert like yards to feet, so let's say I gave you 5 yards. This is like side note, okay? And I wanted you to convert it to feet. I wanted to talk about feet instead of yards. What would you do with this? How would you convert 5 yards to an amount of feet? What's that? Okay, so can we times it by 12? What's the conversion between yards and feet? 3 to 1, right? 3 yards for every 1 foot. Okay. And then think about how fractions work. You basically want the yards to cancel out, right? Like I want no more yards, and what do I want to be left with? Feet. So I want to multiply by how many feet are in how many yards, and it's 3 feet for every 1 yard. So that will cancel out the yards, and then I'll do the multiplication. Since it's all ones in the denominator, I don't have to worry about that, and 5 times 3 would give me 15 feet. Is that okay with everybody? We remember some unit conversion? Okay. So basically, if we want to convert, say, degrees to radians, okay, so let's say I just asked you about this 20 degrees, and it wasn't as simple as the other ones. It's not popping into our head. What I want to be able to do is multiply by something, some quantity that tells me there's this many radians for every specific amount of degrees, so that the degrees will cancel out, and I'll be left with radians, right? So if I can figure out this thing, this conversion factor, like I know for other things, like there's 12 inches in a foot, there's 3 feet in a yard, I need to find one that relates degrees to radians. So look back at our circle. What's an amount of degrees that you know matches a certain number of radians? 180 and pi, right? So you could also say 360 and 2 pi, but 360 and 2 pi are both divisible by 2, right? We want smaller numbers if possible. So we like to use this matchup, that there's 180 degrees for every pi radians. So that means if someone gives me degrees, I can use this relationship that pi radians and 100. And what it would do is it would leave me with a measurement of radians. I'll finish this multiplication to figure it out, and we'll see that in a minute. Okay? So before we leave this and actually do some examples, is everybody okay with how to figure out where degrees are on a circle? Positive or negative measurement. Okay? You should know what an initial side is and what a terminal side is. And if somebody uses the language coterminal, you should understand that the measurement is different numerically, but it ends in the same spot as the angle that they were talking about. Okay? So then we're going to practice the conversion part together more specifically. Okay? All right, so here are 3 degree measurements, and we're going to change them to radians. Okay? So all of them are in degrees. We're converting them all to radians, so this is going to be like a repetitive process once we see how to do it one time. Okay? So the first thing up there is 45 degrees. We already established how many radians this is because we were kind of able to figure that out on our own. If you can figure it out on your own, you're good. But you got to have a backup plan for when it's something weird. Like what if someone gave you like 21.3 degrees? Like I don't know how many radians that is. So remember, what you want to do is you want to multiply by the conversion factor, the thing that relates the unit you currently have to the unit that you want. So I currently have degrees, and I want to relate it to radians. So those are the 2 things I'm dealing with. Where I place them depends on what I want to cancel out and what I want to be left with. Right now, degrees is in the numerator, and I don't want degrees, so I want, in my conversion factor, degrees to be in the denominator so that those will cancel out. And I want radians to be in the numerator, so that's what I will be left with. Okay? Then I have to be able to put here a quantity that I have memorized that are equal things, like 3 feet in a yard, 12 inches in a foot. And for us, that was pi radians are the same as 180 degrees. Okay? So then the degree unit will cancel out. So I'll be left with radian units. And then what I have is I have 45 pi over 180. And then this fraction reduces just like you would normally reduce fractions. Okay? These are both divisible by 45. If you didn't know that right away, knowing that it ends in 5 and 0, you could at least start with dividing each of them by 5 and then just make it smaller, smaller, smaller until it had no more common factors. Okay? So when I reduce this, 45 goes into here 1 time and 45 goes into here 4 times. So I get 1 pi over 4 or pi over 4 radians. 45 degrees is the same as pi over 4 radians. We already did 90, so we're not going to do that one. But why don't you guys go ahead and do the negative 225 and see what you get. Okay? And you should still get a negative answer because you're going to have negative 225 here. That's going to be the only difference. Okay? So go through, can you convert negative 225 to radians and make sure it's in its most reduced form. So do that quickly just to check. So if you set up the conversion factor, you should have then gotten negative 225 pi over 180, and then that can reduce. So if I'm not sure what it reduces by, I could at least start with 5. So 5 goes into 225 45 times, and 5 goes into 180 36 times. Okay. Then I know that 45 and 36 both have a common factor of 9. So 9 goes into 45 5 times and into 36 4 times. So my most reduced answer should be negative 5 pi over 4 radians. Any questions on converting degrees into radians? All right, so then we have to be able to go to the other way too. Does anybody know what the difference is going to be when they give you a radian measurement and you want to convert it to degrees? Alex? Good. You just switch it because if they're going to give you radians, you want the radians to cancel and the degrees to be left. So we're just going to kind of change the way that we're using the fraction. That's the conversion factor. So let's say I have pi over 3 radians. Okay. And I want to multiply that by something that cancels the radians and changes it to degrees. Okay. I still know that 180 pi radians are the same as the 180 and the pi, but 180 is a degree measurement, pi is a radian measurement, and you always want to set it up so that those units cancel, and the units you're left with are the new units that you want. Okay. So then here I'm going to have 180 pi over 3 pi. They both have a factor of pi, and 180 is divisible by 3. So I get 60 degrees is the same as pi over 3 radians. Okay? Is that all right? And so then the same idea here. And then notice part B says 3 radians. It's okay if it doesn't have a pi with it. We get really used to seeing pi with it because it's part of the circumference diameter ratio. It does show up a lot. But just because it doesn't show up doesn't mean that there's something wrong. It just means pi is not going to cancel out when you do your conversion stuff. Okay? So just don't cancel anything out that doesn't cancel out on its own. But let's look specifically at this one. Okay. So again, they're giving us radians and we want degrees. So we want to multiply something that will cancel radians and leave us with degrees. Okay. And again, we have that 180 pi relationship. Just make sure we put them in the correct positions. And then our radians will cancel. So I have negative 540 pi over 4 pi degrees. Again, the factors of pi will cancel. This is 4 going evenly into 540. I don't know, 2 is 270 over 2. Yeah. I get negative 135 degrees. Okay. So just like any other math conversion that you would do, you just have to have this new thing in your head set that 180 degrees is the same thing as pi radians, so that you can use that over and over again. Okay? So the homework tonight is going to ask you to convert back and forth, and then the only other thing it's going to ask you to do is to find those coterminal angles. Like, give me some other measurements of angles that end at the same spot as this one, just like the question I asked you at the beginning about the 20-degree angle. Okay? So did you need that? Oh, okay. Just say so. So find one positive and one negative angle that are coterminal with the angle given. So they're giving me 135 degrees. I have to find another positive angle that would end in the same spot as 135 degrees, and a negative angle that would end in the same spot as 135 degrees. So there's kind of two ways to do this. There's a strict, like a quick number way to do it, where we can just use numbers. But the picture sometimes helps just at the beginning to get the idea. So I'm not saying draw the picture every time, but just to help you remember what's going on here. 135 degrees, its initial side is at 0. And to go 135 would put me in which quadrant? 2. So it would go around till whatever we said is 135 degrees. Right? So how would we find another positive angle that also ends up at that spot, but isn't represented with the same number as 135 degrees? Good. Add in 360, so instead of just going from here to here, I go all the way around and then to there, right? So I would take 135 and add 360 to it, and that would give me a new positive number that ends up in the same place, and that number happens to be, in this case, 495 degrees. So there's an example of a positive angle that is coterminal with 135, okay? How about negative? How am I going to get the negative angle measurement that should correspond with 135? That means instead of starting here and going counterclockwise, I want to go clockwise and end there. So how am I going to figure out that amount? Good. Okay, so you're basically doing 135 minus 360, and with the way that positives and negatives work, that's the same thing as 360 minus 135, but with a negative sign because there's more negatives, right? So I'm thinking in my head, what is this? And I'm getting 225, so this is going to be negative 225 degrees. And you can make sure it makes sense. Would it make sense that negative 225 degrees would get you past 180 and somewhere into this quadrant over here? Makes sense. 225 is more than 180, but it doesn't go 270, so it doesn't go past the next marker. Okay. Is everybody okay with this idea? So ways that we can get positive coterminal angles just numerically. So let's say you didn't want to draw the picture every time. How could you summarize to someone, if you want to find another positive angle that ends up at the same place as that one, you should do what? What did we do numerically with the numbers to figure out another positive angle that was coterminal with 135? We took 135 and we added 360 to it, right? Right here. If I wanted another positive coterminal angle, like they wanted you to list 5 of them, what would I do to 495? Well, I could just add another 360 and then add another 360 and add another 360. So if you want to find more positive values that end in the same position that you're currently at, you should add 360 degrees to it. What about if you want negative values? Yeah, we should subtract 360, okay, until we get a negative value that would end up in the same place. All right, so now if we're doing that with radians, okay, it gets a little bit tricky. So here is 11 pi over 4 radians. So one way you can do this problem is, yes, you can convert that to degrees, find your answers in degrees, and then convert them back to radians, okay? It takes a long time, okay? Or Or you can use the same exact idea that you used over here, but just change your idea from how it happens in degree world to how it would happen in radian world. So what I mean by that is in degree world, you said, oh, if you want a positive angle, add 360. You can add it as many times as you want, and you can get new positive numbers. So in degree world, the answer to that was to add 360 degrees. What is the equivalent of adding 360 degrees in degree world if I want to transfer and start using radians instead of degrees? 2 pi, right? Because 2 pi is the same as 360. So if I want to be able to find positive angles that are coterminal with that 11 pi over 4, even if I have no idea where 11 pi over 4 is, I know if I can just add a loop around the circle, I'll find another angle that's in the same place. But a loop around the circle here is not 360 degrees. It's 2 pi. Okay? Then you have to actually know how to add fractions. Okay? I know, not your favorite, but 2 pi is over 1. You need a common denominator to add the fractions. So this is like 11 pi over 4 plus 8 pi over 4. So I could get 19 pi over 4. Okay. So that is one example of a positive coterminal angle. Ends in the same place. Okay. All right, how am I going to try and get negative coterminal angles with 11 pi over 4? Subtract 2 pi, right? The answer in degrees was to keep subtracting 360 if you wanted new angles that were going negative direction. So in radian mode, that means subtract 2 pi. So I can take 11 pi over 4 and subtract 2 pi. Okay. And we just saw that to make 2 pi over 1, something with a denominator of 4, it becomes 8 pi over 4. So I can think about this as being 8 pi over 4. Okay. What is 11 pi over 4 minus 8 pi over 4? Good. 3 pi over 4. Okay. All right. Did I accomplish my goal just now? What did I need to do to answer this question? Look back up at the directions. I need one positive and one negative coterminal angle. Okay? I found a positive coterminal angle. Did this accomplish my goal of finding a negative coterminal angle? Is 3 pi over 4 negative? No. How is that possible? I did what I was supposed to do and I didn't get a negative. Holly? Well, we'll see if it works out in this case. But here's the thing. How big is 11 pi over 4? How big is one time around our circle in radians? 2 pi, which is how many fourths? 8 pi over 4, right? Is 11 more than that or less than that? Is 11 more than 8 or less than 8? More. So this original angle they gave us was already more than one time around the circle. So when I subtracted the one time around the circle, I still got a positive answer. You could use that as your positive coterminal angle, but you're not finished with the problem yet because you haven't found a negative one yet. What do you think you should do now that you tried to do this, it didn't work out? Well, we already found one bigger than 11 pi. We need a negative one. So when you guys said negative 1, I subtracted 360, right? Or once around the circle or 2 pi. Okay? But I still ended up with a positive. Can I subtract it again? Will I still end up in the same place? Each time I go a lap around the circle, I'll end up in the same place. It doesn't matter how many times I add or subtract. As long as it's 360 or 2 pi, we'll end up in the same place. So if you subtracted it and you didn't get a negative because the number you started out with was so big to begin with, do it again, okay? Take the result that you just got and subtract 2 pi again until you do get a negative value. So you can keep adding and getting more and more different positive values that are coterminal, or you can keep subtracting and eventually getting negative values that are coterminal, okay? So again, remember with common denominators, we saw that this could be 8 pi over 4. Okay? So 3 pi over 4 minus 8 pi over 4 is negative 5 pi over 4. That's a negative value. Okay? So that will work. All right? So the things we should be able to do, we should understand how the degrees and radians work around the circle, the positive and negative direction. We should understand that coterminal means it's something in the same place, just with a different measurement, and how to find those different measurements by adding and subtracting 360 or 2 pi. And we should be able to convert back and forth between degrees and radians like we did before. Is that okay with everybody? Yes. Okay. So your homework is going to be homework 3.